Hello friends, in this video I'll be talking about how to grow crystals and what are the different methods for growing single crystals. So why this is important, because so many times there we do NMR, IR and mass spectrometry that we are not sure about the structure of a compound, but when we obtain a single crystal and then we do single crystal XRD, then we confirm that the molecule is definitely this one, because single crystal gives you all of the information that where are the hydrogens located, where are the carbons located, what is the bond length and what is the bond strength. So in this video I'm talking about growing single crystals. Your diffractometer will trigger. So diffractometer loves the single crystal structure, and if you have a single crystal structure of any organic compound or inorganic compound, then you are definitely confident that the compound is this one, and you can publish single crystals as well without any doubt. So what is a crystal structure? So the determination of the connectivity of the atoms in a compound and the way the molecule or molecules pack to form a solid crystalline material, that is called single crystal. So if you look at this compound, this is how you obtain single crystal structures, and you understand their packing behavior through different techniques. Formation of a single crystal is required in order to do single crystal XRD. What is gained from a crystal structure? Number one, positive identification of a single crystal. Exact connectivity, like where exactly the hydrogen is attached, where exactly the carbon is, where exactly the nitrogen is. So you definitely with 100% confidence can tell that what are the connectivities such as carbon, nitrogen, hydrogen, and what are the linkages present in any molecule, and bond distances and angles, complete identification of the compound. So as I mentioned earlier, that when we prepare a compound, when we synthesize a molecule, then we do different bunch of characterizations such as UV visible spectroscopy, IR spectroscopy, mass spectrometry, NMR spectroscopy. So different correlated techniques we do perform to characterize a single molecule. But if we have a one technique or one result or one graph or one instrument that can give us a definitely 100% surety or confidence about the structure, that is going to be the single crystal XRD. Complete identification of the compound. Intermolecular interactions and intramolecular interactions can also be visualized from the single crystal structure. So solids and crystals. So what are solids? Solids are crystalline material which internally possess long range three-dimensional order. Examples like table salt, sugar, gems, quartz, metals. Solids may be non-crystalline. They are amorphous, short-range ordered or random ordered materials, supercooled liquids. Examples: glass, 1 or 2D ordered solids, fibers, liquid, crystals. So these are the solids and crystals. And then what are crystals? Single crystal lattice is well defined with small repeating units in 3 dimensions. So usually the colorless or colored compounds give you the crystalline look, and then we call them a single crystal. So properties: they possess the extinguish on rotation of cross plane polarized light, clear, generally sparkly, nice regular shape, faces and edges. What is crystal size? Based on a 0.5 mm beam size should be 0.25 to 0.25 to 0.25 mm perfect. So that should be the size for crystal. Gives 0.43 mm diagonal. Smaller can use smaller beam size. Smaller crystals are very possible. Larger crystals can be cut. Techniques for growing crystal, that is really important. So read I am suggesting you to go and read this material. How to grow crystals for X-ray analysis by solution crystallization, written by Olga Chitina, Chemistry Department, Durham University. Key factors in obtaining good crystals. And read Crystal Growing, Peter J. Jones, Chemistry in Britain. See website Paul D. Boyle for and various techniques. Where do I start? Simple recrystallization will give you the single crystal structure. So if you have a powder of an organic compounds and you are wondering inside the lab how do I grow crystals, go and do the recrystallization. That's it. Don't waste any time. So recrystallization is a super easy technique that you can do in the lab. What you have to do is you need to have a powder in a small vial or something in the beaker, or where you take a empty flask, clean flask, put the compound, tiny amount of compound like 100 milligram or 50 milligram is enough, or 10 milligram may be enough depending upon how much compound you have. Then put that compound inside your conical flask, and then now the important thing that second that you are going to put inside that conical flask is solvent. So the choice of solvent is really critical in growing crystals. So you should put that solvent which do not dissolve your product at the room temperature, must not interact with your compound, must not do reaction with your compound, and must not make any sort of bonding with your compound, and must dissolve your compound upon heating. So these are the qualities that solvent must possess in order to be used for recrystallization purpose. So during purification, did you create a crystalline material? Are these crystals big enough? That's a big question. As you can see, the crystal structures are usually obtained in this shape. This is a benzene ring, and this is oxygen, and this is nitrogen in blue color, and these purple one are hydrogens like methyl groups. So it's super clear from a crystal structure that what kind of compound it is, how many hydrogens it has, how many carbon it possesses, how many nitrogen it has, what kind of functional group it contains, what is the connectivity, what are their bond length and bond orders and bond strength. So many things you can tell from crystal structure, and moreover it's beautiful to eye and it's clear to mind. That's how I define crystals. And when you got crystals, you don't need to explain further. That's it. You got the compound, you got the crystal. That's it. Easy. How much material do I need? Depends on the vessel you are going to use to grow the crystals. I like to use 10 to 50 milligram in each trial. Depends on solubility of sample in the solvent. NMR sample generally a good concentration level. What is the goal? To create a single crystal which diffracts on the instrument such that an analysis can be accomplished. Generally, this means to get the material to go from solution to a solid very slowly. Create an environment that slowly changes over time to cause crystallization. Key factors to good crystals: solvent, nucleation, mechanics, time. Patience is the name of growing crystals. It's an art form, it's a luck, it's a patience game. It's a game of patience to grow crystals. You need to try number of samples to grow crystals. You need to try different solvents, different concentrations, different conditions, and you must not be tired and you must not give up. You are going to get the crystals ultimately one day, on a good day, but keep trying. Okay, what do I grow in the crystals in? Clean glassware most of the time. Consider location, consider volume needed to grow the crystals. Usually clean new vials that fit inside one another work well, like for example this one. So there's a big vial and there's a small vial and there are holes inside the big, and this is an anti-solvent and this is a solvent. So this is how you grow crystals through this technique. Solvent choice: polar solvent layered with a non-polar solvent, non-polar solvent, evaporation, or layer with polar solvent harder. So hydrogen bonding is very important in the crystallization process. Consider whether hydrogen bonding solvent might help or hinder crystallization. Amides generally do better with hydrogen bonding solvents. Solvents to use and not to use. Do use benzene seems to be a magic solvent. It has been seen that toluene can do the same sort of thing. Aromatic rings seem to help fill holes in lattice as well. Ethyl acetate works for a lot of compounds. The crystallographer would like you to avoid volatile solvents such as DCM, diethyl ether, and long alkyl chains. This can create disorders and make final solutions more complex. Caution: benzene is a known cancer hazard. So if you can try to avoid, if you can avoid the benzene as a solvent, then avoid it. But if you can't, then go for it. Use it. Crystal is more important than being the hazardous chemical benzene is. Next is solvent layering. Layering must be very careful. Place a solvent between the two layers. Do not disturb the vessel. Set it so you can view it without moving it. Grown by layering a solution of methylene chloride with hexanes and a drop of benzene. Vapor diffusion. Good for milligram amounts. Volatile solvents slowly create a less desirable solvent. Need to be aware of vapor pressures of solvents. Used a diffusion chamber with compound in the acetonitrile and ethyl ether in the outside chamber. Slow evaporation is really important for growing crystals. Allow the material to crystallize out as the solvent evaporates. Keep the solution clean and covered to avoid dust particles. Slow evaporation, benzene and hexane. Evaporation methods: tighten or loosen cap, like in this figure. Use of needles through the septa of vial governs the speed of evaporation. Inside a desiccator with desiccant, some use a vacuum desiccator. Use the NMR tube. Often crystals have been obtained by allowing the solvent to evaporate slowly from the NMR tube. Remember to keep the tube covered to avoid dust and dirt. Slow cooling. Standard recrystallization technique. Must perform this slowly to work well. Slow reduction of the temperature is best. Use fridge or freezer with vial inside of a Dewar glass jar insulated. Crystallized from ether at -35 degrees centigrade this compound. Combined methods. In some cases, combining techniques works well. We have seen many compounds crystallized while a soluble solvent layered non-soluble solvent, then placed in a fridge or a freezer. Crystallized from concentrated toluene solution layered in pentane held at -35 degrees. Improve heavy atom and crystallization. Heavy atom present. Alcohols and amines make derivative with p-bromobenzoate. Include aromatic components in derivative. Crystal was 0.1, 0.05 times 0.05 mm grown. Benzene layered with hexane. Counter ions are ionization. Change a counter ion in the complex. Ions of the same size tend to pack well. If neutral compound does not crystallize or is liquid, create an ion. Deprotonation or protonation. Good to confirm the identity of the material. Follow this reference for more details. Learning. Chemist is often in the best position to grow single crystal. Compound properties, solubility and reactivity. Type of crystal grown can lead to understanding of possible changes needed to get better crystals. Solidified oil, dendritic, microcrystalline powder. Key factors to good crystals: solvent, nucleation, mechanics, time, patience, odd form patience. Thank you for watching, and if you have any questions regarding growing crystals, please drop your comments below. I have grown number of crystals throughout my research career during my MPhil and now in PhD as well. Feel free to ask your questions in the comments regarding crystallography or crystals, and I'm happy to answer. Thanks for watching. Take care. Bye.